Hello everyone, this is part 2 of the object-oriented programming video series, and if you haven't watched the object-oriented programming video I made earlier, go ahead and watch it right now before starting this one, because we will be practicing what we learned in that video in code. Okay, so first of all, let me give you some overview of the kind of example we're going with. We are not going with omelets, as I extensively used in the last video. What we're going to do is we're going to create a living thing base class, and then we're going to make three classes that inherit from it: dog, cat, and human. And then we're going to apply all the things we learned, and I'm going to teach you some neat tricks that you can use in order to get the best use out of that kind of hierarchical structure. Another thing to remember is not to make your hierarchies too long downwards, and also not to make your hierarchies too wide. Okay, there are ways to get around that. If your hierarchy is too wide, in other words, there are tons and tons of objects, inheriting from living thing, then it's going to create, management headaches for you. And then if there are too many things, going downstairs, like for example, dog then inherits from there's a Alsatian is inheriting from dog is inheriting from living thing, and it goes way 4, 5, 6 steps down, then it's going to create some kind of headache for you. So there are ways to go around that. So basically it's kind of a like smart thinking will help you, because the whole point of object-oriented programming is make it easy for you. Okay, so if it's turning into spaghetti, you're not doing it right. Okay, so let's get down to it. Let me create a folder and call it OOP2, and let's create our first script. Okay, so this script is going to be our base class, so I'm going to call it living thing. Oh no, living things, no, living thing. Okay, always make them singular. That makes it easy for you to rationalize it. I'll give you an example later. Okay, so now this is going to be our base class, which inherits from mono behavior, because we assume that our objects will actually be something inside the game. So a dog could actually be a dog running around. So that's why the living thing is inheriting from mono behavior, since this video is in the domain of game development. Now, first of all, what we have to do is imagine the things which all living things must have, with respect to our game. So what we assume is all living things are going to have health. Okay, so we say float health, and let's default it to 100. Okay, now this is private. We don't need to make it private. We actually need to make it protected. The reason to make it protected is that the dog itself, or the living thing, dog as in anyone who inherits from this base class, should be able to change their health, but no one outside the system should be able to tamper with the health of a living thing. Okay, that makes sense. So if the management of the health is the living thing's responsibility, no one else has the right to do that. Okay, now for example, in the example I gave earlier, for example, a grenade explodes. It should not have the right to go in and reduce the damage of a living thing. Okay, it should just tell the living thing that you have been damaged, and the health management, what to do when my health reaches 0 and all that stuff, is basically the living thing's own responsibility. Okay, so Next, what we can say is, let's say protected. Mm, what else? Age. Let's say age. Okay, let's go with age. And it should also be a float. And let's default the age to 0. Okay, 0 because let's assume they just get born and then they're gonna increase their age or something. Oh, something went wrong there. Okay, now, okay, sorry. For some reason, float isn't happy. Okay, now this is the basic stuff. You all already know that. The interesting thing is this. What we're gonna do is now say public living thing this. No, I should say. Okay, what we have just done now is basically we have created a constructor. Okay, so this is the reason this is a constructor is because the name is exactly the same as the mono behavior or as the main class. Okay, that makes it a constructor. Okay, now sorry, you don't need void for that. Okay, that's why I deleted it. Now the the only identifier or the only way to make a constructor is that the name is exactly the same as the class. So in other words, let me give you a quick example. When you say vector 3, no, not working. Ah yes, it's not working. Let me quickly close it and restart it. Bear with me. We're gonna do some interesting things, and especially I have a hunch about a few things that you might have missed in your university education because they're kind of tiny little tricks which you know people miss. Come on, is it even working? No, something is working. Oh yeah, it's taking way too long. Okay, now we say, for example, when we say var x is equal to new vector 3. Now this thing, these three things are based, these two, in fact three, these three things are actually constructors of vector 3. So you can either create a new vector 3 without giving anything, or you can create a new vector 3 by giving an x and y, which will go here between these brackets for our living thing, or you can create a new uh, you know vector 3 by giving these three things. So basically what this means is when the Unity people created the vector 3 struct, they gave it three separate constructors. Okay, so like this. So you can have multiple constructors to define different use cases. Okay, so what that does is, oh, okay, no, okay, we'll fix that later. Okay, so basically what that means is you can have a constructor for that takes only health, or another constructor that takes only age and defaults the health to this value, or you can change the health. So basically it's up to you. Now what we're going to do is we're going to ask for the health, okay, because we think health is something that should be given to us, and age, okay. So we're going to say float, health and age both should be given to us. But we also think that if they do not give us any of those things, it's fine either way, because we're going to then default these things too. Okay, and another thing is, I think it's saying don't use an empty constructor because it's redundant. Is that what it said? No. Uh, okay. Oh, now no, we need since we added a constructor, now we need to tell it that an empty constructor is a possibility as well. So now don't either ask for both of those things or don't. If you don't, then of course they're gonna stay default. But if you do, then you're gonna say health is equal to the one that has been given to you. Okay, so health. Then we say age. So age and the one that has been given to you now. Okay, now what we have done is basically given any person who creates a living thing uh, to give them a starting health and age system. Okay, then we can of course create different kinds of methods for it. For example, public. No, it should not be public. It should be protected, and also all these things should be protected. I'll let you know why. Protected, let's say die. Okay, so all capital letters, too ominous, I guess. Protected void die. So basically, anyone can, or not anyone, when this object dies, their health system, or the declaration of death will be done here. Okay, so bool is dead, defaults to false, and die as well. So I'm not going to create the whole system because we're just covering the concept. So basically, is dead is equal to true, and all the rest of the stuff that you need to do in order to declare this entity dead, and all the cleanup work will go here. Now comes slightly more interesting stuff, which is a script that inherits from this. Let's say it's called dog. Now what's interesting about the dog thing is, let me give you. First of all, we're going to inherit this from, of course, living things, which inherits from mono behavior, so dog is a mono behavior. Okay. Now, another important thing we need to understand is that this living thing class, we did not make it so that it could be instantiated inside the game. In other words, you cannot say create a new living thing. You can only say create a new dog. A living thing getting created is kind of a side effect of creating a dog, because a dog is a living thing. So what we do is we make this abstract to ensure that this class is only here so that other classes can inherit from it, but it doesn't accidentally get instantiated because the functionality of this thing isn't complete. Okay, now another important thing to do is we want to do something special for the die method. Why? Because what makes a dog's death different than what makes a dog's death different from any living thing's death? For example, a dog, if a dog dies, maybe it creates a different sound effect. So what we want to do is we still want to make sure that the die functionality of the living thing gets run, but our dog can do its own thing as well, as I explained in the previous video. So what we're going to do is make this die method a virtual method. So it's protected as well as virtual. In other words, no one except dog can run it. And also the dog has the ability to override it and add in some additional functionality to die. So what we're going to say here is override die, and now we say protected override void die and then base to die. So basically base to die is saying, okay, I'm gonna do what you want me to do, and this line is gonna say, okay, this line basically goes back or above to the living thing and runs what's here. So what we can do is either add our functionality before the base or after the base. Okay, so in our case we can add our functionality before the base. So we say debug.log and say, oh no, the doggy died. Okay, so let's go with that. And I think I misspelled that. What? Oh, sorry. Okay, something is really fishy today. Let's add that in there. We'll have to restart. Oh no. Okay, so we'll add that later. Another thing we are going to do is the dog is going to have its own constructor. Okay, so there must be some functionality that is needed. Now, the living thing also requires these two things, or you can create a living thing without these two things. But what if the dog wants to change its health, but the health is in the living thing, and the dog is technically not allowed to mess with the living thing code? Oh, sorry, mess with the health code. So what is the dog gonna do? So basically, the dog is gonna have a public constructor because a dog can be created by outside forces, and let's say dog. And now what we're going to do is dog's constructor is going to say, give me, okay, now the dog wants health, but health is basically stored in the living thing. And so basically it wants health and age, but it cannot directly change them like we did here. So this is what we're going to do, and this is what you should do. We say the dog asks for float health, sorry, health, comma, float age. But it cannot say, although let me show you, health. If I say health, float living thing dot health. So basically, since a dog is living thing, it does have access to these variables, protected variables, but it is bad manners to change them directly here. Why? Because if we want to change, or if we are diagnosing the health management code, and we'll end up here and we won't know which of the children is messing around. So we could have a dog, we could have a cat, we could have a human, and then we'll have to open all those scripts to see who messed with the health. So that's why wherever the variable or field lies, that's the only place you should ever mess with it. Okay, so we cannot say health is equal to health. Okay, and another important aspect is if we removed this one. For example, if we disallowed the living thing to be created without providing these two things all together, then doing this would still give you an error. Okay, so you are forced to choose the way I'm about to teach you, which is you put a colon here and you say base, and then you directly run the base constructor here. So what's happening is a dog is being created, and by virtue of that, uh, you know, sorry, I think I missed basic brackets. Okay, so the health that arrived here when a dog was created was directly passed from here to here. The age was directly passed from here to here, so it ended up here. And when a dog is created, a living thing is automatically created as well. There's no other way around it. So you can leave this just like this. The dog actually was trying to fulfill the requirements of being a living thing by asking for these two things. Maybe there's something specific the dog wants, which is here. Let's say a name. But name, it can also, no, yeah, name, doggy name could be something only a dog has. Okay, so something that only the dog has goes here. And you can also ask for that here, pass these two here, and the other thing directly feed it into a field variable right here. But that's still not the most powerful thing you can do. Now what we're going to do is we are going to create a kind of a universal uh, census system. For example, we say public static list yes, of living things. Okay, so we're going to create, and we're going to call it all, no, it's all living things. And also, we are going to, whenever a new living thing is created, we're going to add that into all living things. And I have a spelling mistake. Okay, so we're going to say all living things dot add this. So this way, now we have a list going of all the living things that have ever been created. So inside this list are all the dogs, all the cats, all the humans, and they know that they're dogs and they know they're cats, but this list treats them only as living things. So when that dog gets created, this is gonna get run, and that dog is gonna get added into the living thing list. But what if we want to talk to all the dogs only? So what we're going to do is create a similar mechanism of census here, and we are going to say all, no, this one needs to be all dogs. All dogs, okay? And we're going to say all dogs dot add this. So now we have a way of, universally dealing with objects based on their type. Now, let's quickly create, let me just copy, no, I can copy paste some of it, but not all of it. Yeah, we could rename those. Okay, let's quickly create a dog and a cat. Okay, create C# script cat, and then we say create C# script human. Now let's open these two scripts. and let's see if the pasting works. This needs to be cat. This needs to be all cats. And this needs to be living. Okay, there you go. Cat is done. Let's create a human. Oh, sorry. Okay. This needs to be living thing. This needs to be all humans. This needs to be all humans. And this needs to be human. Okay, there you go. Now we have three different kinds of living things inheriting from this living thing. They're all individually asking for health and age and passing it on to the living thing. And when they die, they basically just let uh, the living things die method run, but they say something different. So that saying part is basically going to be debug.log, but in your actual game, it can be anything. Okay, this is bugging me. Debug. Okay, why wasn't it there in the first place, though? Oh well. Now we say, now the human says, oh no, human. Okay. And everyone else will say their own thing, which will basically during testing tell us that yes, they perform their separate functionality. They did not just run this, and when, for example, a grenade explodes or something like that happens, this will ensure and show to us that yes, we can run this kind of separate functionality as well. Also, what we have learned today is that management of different things is easy if you just know how to pass along the information to the parent. Okay, this way it doesn't get messy. Otherwise, if you didn't do that, you would have ended up doing, changing the health variable of living thing directly inside the children. And most people often, get kind of a wrong understanding that making a variable in the living thing is just another way of making it available to all the children. What they still play with those variables in the children, which is the wrong approach. It belongs to the living thing. It should be managed in the living thing. Okay, the dog should do its own thing. Dog should do dog things, which are here. It should not, play with the fields of the living thing. Although they are accessible, that does not mean you can directly or you should be changing them all the time, because that will make it messy for you. Now, next step is testing. Okay, so what we're going to do is, in order to test this, we are going to create a 3D object. Let's call it cube. No, let's call it animal manager. Okay, and we're going to create a new script called animal manager. Animal manager. Okay. Now I'm going to attach that script to. I'm going to attach the script to the animal manager, and let's make it. So what this animal manager script is going to do is we're going to create a lot of different dogs, cats, and humans, and we're going to call method on it and see what happens. Okay, and also we're going to separately count them in order to see that whether all of those things are being individually as well as separately counted. For example, when we create a dog, does a living thing also get created? We're going to test that. Also, we're going to call things on living things. For example, we're going to say living things dot die, but the dogs are still going to bark. That's going to prove to us that despite residing inside the living things list, they still know that they're dogs. Okay, so let's do that. For the animal manager, we're going to say a public list. No, let's make a, yeah, let's make a packaging class spawn order, and let's say int how number to spawn, number to spawn, and oh, not private, public, and we are gonna create an enum. Okay, so this is not exactly the uh, related to this video's lesson. I'm just creating an animal manager to make it easy for me to test. Okay, there you go. Now we're gonna say public package first line, public animal, type animal. Oh, sorry. Why are you not this way? Okay, there you go. I don't know what's wrong with my Visual Studio these days. Okay, there you go. And now we're going to do this. Seriously, I'm going to have to restart my Visual Studio again. Okay, one. That's needs to be capital, I think. Sorry about the delay, guys. Okay, then we are going to say public list of spawn orders. So we can quickly change the, testing and spawn different number of animals quickly. Okay, if you're wondering why I did all that, let me show you. I did this for this spawn orders. I'm gonna create 3 spawn orders, press enter, and then I'm gonna say create 5 dogs, 2 cats, no 4, okay, 8 human. Okay, so this way it will make it easy for me to quickly populate my list. Serializable made making the enum serializable allowed this to appear, and making the spawn order serializable allowed this whole thing to appear. Okay. Now, and since they were public, that's why. Okay. Now, once we have spawn orders, what we're gonna do is Control Shift M, start, and we are gonna say for each spawn in, oh well, okay. For each spawn order in spawn orders, what you're gonna do is spawn order dot no let's for int I for spawn order dot number to spawn, enter. So then here we can say switch. Since the number of items is small, I'm gonna do that. Spawn order, no, not for that, for type animal. No. Alt enter. No. Okay, didn't put that properly. Why is it working? Oh well, I can do it another way. Sorry, I'm a little groggy today. Ah, okay. Let me try it one more time. Dot. Yes, it worked. Okay, there you go. Now we can create this of all the living things. Okay, remember we want to test if the list of living things, since although we are creating different kinds, we're going to intentionally put them under living thing, because the code we are interested in called die is inside the living thing parent class, and the other ones are overriding it, so we are happy, we know they're going to do their own thing. Spawned living things. Sorry guys, I know I'm rather slow today mentally as well, so apologize if you're getting bugged by my, anyways. So what we're gonna say is spawn living things dot add, and we're gonna create new dot, and then we're gonna say its health is 23 and age is 54. Okay, let's go with that. You're gonna have a random or whatever is your game requires. Then we're gonna create that many cats, and then we're gonna create that many humans. Human, and then we're gonna say cat. Okay, so now our list is populated. Okay, That's all what we were doing here. Now let's test it. Okay, so we say inside the start, for each spawn living things, for each spawn living thing in spawn living things, say spawned living thing dot die. No, spawn living thing dot, oh sorry, it's a living thing and die is protected, I think, is it? Yeah, it needs to be public because an API method. The dog make it, okay, dog, or dog can make it public, I suppose. Let's test it. No, it's gonna give me an error. I'm gonna say access rights, yeah. So the API method needs to be public. Oh my god, I'm so rusty. Okay, now we can say that. Now, ideally, what's going to happen and what should happen is, let me show you again. The list is storing them as living thing. We are calling the die on them as living thing, but they should be smart enough to know. Okay, if you have watched the previous video, you know how powerful this thing can be if you really understand what's happening here. This is a really powerful concept, storing things as their parent class and calling methods on the parent class while the children do their own thing. Okay, now let's go and test this. Before doing that, yeah, I think that's it. Let's go and test it. Oh, I don't have to make spawn orders again, but I would. Oh, I don't. Okay, spawn living things are right now 0. Let's play. And now we have no spawn items and a null reference error. Well, at least we have something. And what? No, sorry. No, there's no very much. All living things. Oh man, seriously. Sorry, I forgot it's you have to create a living thing list because it's not a value type. We're gonna have to do the same thing here. We need to create a list for it to populate. Let's see if I saved all the scripts. Okay. Unpause it. Play it again. Let's see if we have a list of items. Now we have another error. Oh, same thing. In fact, it's gonna happen in cat and human as well. New. Sorry. Okay. Exit. New. Cat is gonna. Yeah, I know. I made a boo boo. Okay. Now, if you see that we have a populated list of living things, and then we have 5 dogs, so it should say 5. Oh no, a human died. Okay, so it created all humans. Did it? Yes. Or maybe I didn't change the. Oh my god. Seriously? Okay, now I think I deserve oh well. I can't wait for the comments. Control S. Control S. It worked, but all the logs were the same. Okay. Did I just make two cats now? Cat? Oh wow. Seriously? Dog. Okay, well it worked. You can see. 548. Okay? So each of them did their own thing despite being in a list of living things. Okay? Also, and other powerful things we can do is you can directly talk to the all the dogs in your game by simply doing dog dot all dogs. Okay, this is also a really powerful thing. You can talk to all your living things. Since if they die, you're gonna be doing cleanup work and die as well. So always keep this list reliable and it's static. So basically, it's the same thing. If you remember my previous video, it's basically the same thing as writing on the recipe page. Okay, so I hope you guys enjoyed this video despite my numerous boo-boos. But well, I am getting up to speed slowly. And thank you for watching. And please, please subscribe. Take care.